All right, welcome to the second half of section 8.1 as we continue to talk about right triangle trig. So in our last section, we identified how we find the 6 trig ratios, and we came up with our little mnemonic device to help us remember, SOHCAHTOA. So sine means opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And again, it depends on where your angle is that you're trying to find. The opposite will be across from the angle. The hypotenuse is always across from the 90-degree angle, and the adjacent leg is attached to the angle. So we went through and we did some problems together, and we stopped right here at the end, and I asked you to go watch the videos that are linked as well. I'll also be asking you to watch one other video called Getting Triggy with It at the end of this particular video as well. If I can figure out how to link the videos on to the instruction, I will do that, but as of right now, I cannot figure that out. So our next example is asking us to calculate it. Now, if you watch the videos, especially the one that was Shut Up and SOHCAHTOA, which is just a cool history little piece about it, but in one of his verses he says to make sure that he puts his calculator in degree mode. Now, depending on which calculator you're using, you'll have to make sure that you check that, because if your calculator's not in degree mode, then you're going to get everything wrong. If you're just using a basic scientific calculator, you will see down here really small, it says DEG. That means that your calculator comes programmed in degree mode. There's another type of measure that we can measure angles in, and that's called radians. And in about 3 weeks, we'll be learning about radian measures. And you can see them right here. So I just press this DRG, so degrees, radians, and graduals is what it stands for. The degrees is what is programmed for. This is radians. And so instead of there being 360 degrees in a circle is made up, a whole circle is 2 pi rotations. And then the last one you'll use, I think it's in physics that you'll use the graduals as another way to measure an angle, or to measure a sector. So those are the 3. So if you're just using a basic scientific calculator, it will just come programmed in degrees, as I can tell that it's in degrees. However, if you're using a scientific or a graphing calculator, it actually comes programmed differently. Let me just reset this. And where you need to go change it to is that when you go to mode, its normal setting is that it's in radian mode. And it only has 2 settings, radians and degree. So you'll need to go down to where it says radians, click over to degree, and then press enter, and then that calculator will put it in degree mode, which is going to be critical as we do them. If I don't change this, let me just show you how I'll get a totally different answer. So on example 2a, it wants me to do the inverse sine. So I'm going to do second, and then I press the sine button. Please don't say sin as you're saying that. Remember to use your math words, not how you're not in language arts. So that's my inverse sine, and I put 0.5, and it tells me that my answer is 30 degrees. If I forget and leave this calculator in radian mode, when I go to do the inverse sine of 0.5, it does not give me 30 degrees because it's in the wrong mode. So again, I have to go press mode, go down, make sure that's in degrees. And if I go back up and I enter this, it will sure enough tell me that it's 30 degrees. So please, please make sure your calculator is in degree mode before you start doing computations with the trig functions. So let's finish this up really quickly. Hopefully you've already been doing it while I've been gabbing. So inverse tangent of 6 rounded to the nearest degree is 81 degrees, because all of our degrees will be rounded to the nearest whole degree. And then my last one, I have inverse cosine and of 0.86. And it is rounded to the nearest degree, 31 degrees. Okay, so that's just practicing using our trig buttons on our calculator. Finally getting to use them after all these years. Finally. Okay, let's move on to example 3. On example 3 and example 4, they're going to have us now do some calculations. On example 3, we're going to go find the angle, the missing angle. So we have to write an equation involving sine, cosine, or tangent that can be used to find theta. And when we go to solve, we'll always round to the nearest degree when we're talking about our angle. So I'm going to blow this up a little bit so hopefully you can see it a little bit better. On my first example, they gave me all 3 sides. So I could choose any of the 3 trig ratios to solve it. So I'm just going to write up here at the top my mnemonic device to remember it. So SOHCAHTOA, and this is my angle this time. So if I'm going to label them, this would be my opposite. Here's my hypotenuse across from the 90-degree angle, and this is my adjacent. So if I were going to use my sine of, we don't know that angle, that's what we're trying to find, so sine of theta is equal to opposite, which is 3, over hypotenuse, which is 5. Or I could choose to solve it using cosine, and cosine of theta, well, cosine is adjacent over hypotenuse, so the adjacent is 4 and the hypotenuse is 5. Or I could also, because I have all three sides, could also solve it using tangent. And tangent is opposite over adjacent. Opposite is 3, and adjacent is 4. Now I'm trying to get theta by itself on any of these three equations. And they're multiplying by sine, so maybe you're thinking, oh, well, let's just divide by sine. But the problem is we have to do a little bit, write it just slightly different so that we can know what to punch in our calculator. So if I'm dividing by sine, that is the same thing as multiplying by the inverse of sine. This and this are the same thing. This is down in the denominator, so if I move it to the numerator, it becomes a -1. And if I have the inverse of sine times sine, which we've used this idea before, they cancel out, and so I'll have theta equals. Now if I do the inverse of sine on this side, to keep it balanced, I have to do the inverse of sine on this side. So I take my calculator, and I do the inverse sine, and I need to do, I'm just going to slide this over, 3/5. So I can either enter it as a fraction like that, 3/5. I apologize for those little beeps. I get 3 and I use the fraction button 5 and I get 36.8, so that's 37 degrees. Okay, that's solving this equation. Now let's try the other equations that we also came up with. So cosine, they're multiplying by. So again, I would divide by cosine, but rather than dividing by cosine, we're going to multiply by the inverse of cosine and the inverse of cosine. So these will cross out and I have theta equals, and I just need to do the inverse cosine of 4/5. This time I'll use the division bar just so you can see it doesn't matter which of the two buttons. And again, I get exactly the same answer of 37 degrees. And the last one, they're multiplying by tangent, so that I do the inverse tangent. So that crosses those out. An inverse tangent. And so if I do the inverse tangent of 3/4, now maybe you are like, oh, 3/4 is 0.75. Well, you could also do that as well. And you'll still get the same answer of 37 degrees. So if they give you all three sides and they're asking you to find an angle, you can solve using any of the three. You don't have to do all three, but you could use any of the three. But that's not really truly the way it's going to be on your assignment. Instead, it's going to look more like this one, B, where here's your angle, and they tell me this side, which is directly across from it, so that means this is the opposite, and this is my hypotenuse. So I need to go find the trig function that has opposite and hypotenuse. I'm going to slide my paper up for a minute. Opposite and hypotenuse. Oh, well, I'm going to use sine. It won't be tangent because it doesn't even have a hypotenuse. And on cosine, I'd have to have the adjacent. And they gave me the opposite. I could go find the adjacent, but no sense doing more work than I have to. So I'm going to use sine. So my equation is sine of theta equals opposite, which is 9, over hypotenuse, which is 13. And then again, I just need to solve that. So if I'm trying to solve for theta, I need to do the inverse sine on both sides. And then I'll just take my calculator and do the inverse sine. I'm going to slide this over so we're off the glare. Hopefully you can kind of see that. I have 9 divided by 13, or you could do 9/13 as a fraction. And I get 43.8, so my theta is approximately 44 degrees. So on today's assignment, you're going to see some of those where you're going to need to find the missing angle. The last type of examples that we're going to do is now we're going to find the missing side. And again, you're going to have to write an equation involving one of these three trig ratios that can help you find x. Now, if we're talking about a length of a side of the triangle, lengths will round to the nearest tenth. So when we're finding sides, we'll round to the nearest tenth. When we're finding angles, we'll round to the nearest whole. So here's my first one. We didn't draw them this time. And I apologize for my not very good triangles. Before I even start, I'll apologize. And we're going to say that this is 30 degrees. So this time they gave me the angle. And here's my right angle. They tell me my hypotenuse is 8, and they want me to find this side. So it looks like I know I have my hypotenuse, And I have this side, which isn't the opposite. This is the opposite. This is attached to the angle, so this is my adjacent. So which trig function does adjacent and hypotenuse? Again, I can go up to the top. Adjacent and hypotenuse will be cosine. So my equation is going to look like this. The cosine, but now it's not theta, now I know the angle is 30 degrees, is equal to adjacent, which I don't know, over my hypotenuse, 8. Now I have an equation, I just need to solve it. I'm solving for x. Well, over here's x, the only thing that's with it is they're dividing by 8. So I'm going to times by 8. I'll times by 8. I'll cross this out and I'll have x equals, and I just need to take my calculator and do 8 multiplied by the cosine of x. Clear that out. So 8, not the inverse this time, it's just the cosine of the angle, which was 30 degrees. And again, remember we're going to round to the nearest tenth, and so it will be 6.9. I don't have a unit today because it's not an application problem, or we didn't put any units, so we'll just say 6.9 is how long the length is. Okay, that's one type. Let's go on to the next one, B. That was finding the adjacent leg. So this time, draw my triangle again, slightly different. Oh, there we go. Here's my 90-degree angle. I'll better mark it because it's a little bit difficult to tell. This side is x, this side is 10, and my angle is right here, and we're going to say that it has 22 degrees. So it's a 22-degree angle. Again, I need to first decide which trig ratio is going to be the best one to use. I have 10, which is, here's my 90 degrees, so it's not a hypotenuse. Here's my angle that I'm looking at, so this is the opposite. Straight across, and this is attached to it, so this is my adjacent. So opposite and adjacent. I'll give you a minute to think which trig function is opposite and adjacent. Hopefully you said tangent, because that's right. Opposite over adjacent is tangent. So the tangent of 22 is equal to opposite. We don't know x over adjacent, which is 10. So now again, it's a lot like solving this one. I'm just trying to get x by itself. They're dividing by 10, so I need to multiply by 10. And so I just need to do 10 times the tangent of 22. You do not have to press the times sign when you enter it in. You just go 10 and then press tangent. They'll just know that you want to multiply it by 22. And again, I round to the nearest whole or nearest tenth, and this is less than 5, so it just stays 4.0. So x equals 4.0. And we leave the 0.0 so that they know that it was rounded to 4, not that it was exactly 4. Okay, last type. And this time, my picture looks like this. And again, I'm not really drawn to scale. That's my 90-degree angle. We're going to say this is, even though it doesn't really look like it, it's 60 degrees. And this is 300. And I want you to find this piece this time. So this time, I'm trying to find the hypotenuse. And the 300 is across from the 60, so this is an opposite. So which trig function deals with opposite and hypotenuse? Again, I'll give you a minute to figure out which. Is it sine, cosine, or tangent? Opposite and hypotenuse is O and H, so it is sine. So the sine of 60 degrees is equal to the opposite, 300, over the hypotenuse, x. This time the equation is different. It's not like example 4a and b. Now the x is in the denominator. So the first thing I need to do in order to solve for x is I've got to get it up into the numerator. So what I'm going to do is I'm going to times by x on both sides. And then we'll talk about the shortcut in just a minute that you can think about. So I'll times by x, this, cross these guys out, and this will be x sine of 60 equals 300. Remember, I'm just trying to get x by itself, so I'll divide by the sine of 60. Just takes a little bit more work. So x will equal, these will cross out, and I just need to go do this calculation in my calculator. So I'm going to take 300, and I'm going to divide by the sine of 60. Rounded to the nearest tenth, it's 346.4. Oops. So when you go to watch the video called Get Triggy with It, they'll actually talk about how to solve each of these, and the gentleman kind of gives you a little shortcut. And he just says, you know, when you're looking at an equation like this, it's kind of like a proportion, and this is like your 1x, and he says, oh, you just multiply those two. So if x is up top, then you just multiply these two together. Just multiply those two together. So he doesn't really think too much about it being an equation. And then the trick that he says when you get to one that looks like this, let me get rid of this piece. He says what we're going to need to do this time, if x is down in the denominator, then you're actually going to switch these two positions, is what he says, which is what ends up happening, right? This 300 and the 60. But don't become too caught up in the shortcut. Make sure you just know the basic algebra to solve for x, and you won't have that problem. But it's just kind of a shortcut they tell you. So these two just switch position, and that's when you divide. So you either multiply, if x is in the numerator, you'll multiply. Cross multiply is actually what you're doing. And if the x is in the denominator, then you're actually going to switch these two to do your calculation. On every problem today, you need to have the equation involving either sine, cosine, or tangent, just like we had here. Here's my equation here. Here's my equation here, and then you can go straight to the answer if you choose. Again, you don't have to show this algebra work if you don't want to, but make sure you understand how to get that algebra work. All right, so finish up your 8.1 worksheet, getting all the problems completed. On the front half is finding all the 6 trig ratios. Make sure your answers are always in lowest terms. So the trig ratios on the first half of your assignment, and then on the second half, it'll be like example 3 and example 4. Where you'll be finding the missing piece. If it's an angle, then round to the nearest degree. And if it's a side, if you're missing a side, you round to the nearest tenth. All right, good luck, and we'll see you next time.